Hello everyone. Thank you for the introduction, Danielle. It's great to be at SmartCon. It's Barcelona, it's a dream come true. I want to talk to you about DECO. Last year at SmartCon 2022, Dalia presented our vision for this amazing technology that we've been building. And I figured that this year it's time for an update on what we've been doing. I am going to start off by just giving you an intuition of how DECO works and what it can do for your project. I'll go on to introduce this new tool that we've been building called the DECO Playground. And then finally, I'll go through a bunch of other improvements that we've been adding over the months recently. So in a nutshell, DECO is an infrastructure tool, a building block that you can use in your application to make proofs over statements from HTTP requests. DECO is a three-way interaction between a prover and a verifier, so far very Web 2. Again, this interaction is over the TLS protocol. But with DECO, we're introducing a new party to the interaction called the verifier. And the job of the verifier is to make sure that the interaction between the prover or the client and the server or the data source is actually happening, or actually has happened. And also to check that the statements that the client, the prover, is making about that interaction, about the response from that API endpoint, are valid and correct. So what is the problem space we are attacking with DECO? So imagine you're building an application, a decentralized application, that's why we're here, that needs to use user personal data. And it makes sense, right? Personal data is very valuable. You can build a lot of useful applications on top of it. It's usually behind an authentication screen, and for good reason, right? It's private. Nobody wants to give that away that easily. And so now you have two problems, right? First of all, how do you access this data? How does your application access this data without exposing user credentials or user secrets? And the second one, which is more subtle, is how do you make sure that your application uses the least amount of data needed to perform its function? And in fact, how do you prove to your users that your application doesn't abuse its power that the user give it? So we've been designing and building DECO to solve this problem. Like I said, DECO is a tool that makes HTTPS requests and and applies predicates on top of the responses from these requests, all in zero knowledge, so preserving the user's privacy. Using DECO, you get three main benefits. First of all, provenance, which you don't get via TLS, but with DECO, you can prove that the user has accessed a specific data source and a specific resource on that server. The second one I've talked a little bit about is privacy, obviously very important, but with DECO, users have complete control over what data they keep secret and what data they keep public. And finally, and I think quite amazingly given the first two properties, is compatibility. DECO is fully compatible with existing Web 2 legacy APIs. It works without the need of these servers, these companies, these institutions to change any of their infrastructure, to install plugins or use proxies or anything like that. In the grand scheme of things, in the family of Chainlink products, DECO is firmly planted in the data tree. Again, just to reiterate, it takes data from Web 2 and builds proofs on top of that data for you to publish on chain and consume on chain, all while preserving user privacy. So let me give you a few use cases that we've been experimenting with with partners in the industry and in the academia. First of all, KYC, it stands for Know Your Customer. This is actually a legal requirement in certain fields, particularly the ones we're interested in, the financial world. KYC basically means that you shouldn't do business with people or entities that are on some ban list that the government maintains. You can think of it as lists of money laundering organizations that are known to engage in money laundering and things like that. So that's a legal requirement. And we've built a POC with an external company, a proof of concept with an external company, where we used the Persona API to get DECO to build attestations that the user, of the proof that the user is not on one of these lists that are consumable on chain and users can then benefit. The identity space, it's a sort of a broad spectrum of technologies and problems, and it's very heterogeneous. But I think that makes DECO particularly useful in this space because, like I said before, DECO does not have any requirement on the data source. In fact, the data source doesn't even know that DECO is being used. It's fully compatible. So you can access data sources like government institution APIs or banking APIs. And in fact, speaking of banking, we've built a POC with partners that configures DECO to build proofs that users have enough funds in their traditional banks, so off-chain. They have enough funds to use that as collateral to get a loan on-chain. But most of all, and I think personally the reason why I'm here, I'm curious what all of you, the builders and the product people in this room, are going to come up with when you're using our tool. So, to help with that, we've been hard at work building a new tool called the DECO Playground. The DECO Playground is a tool just to help you configure the DECO protocol to make sure you get the exact attestation that you want to obtain and that works in your application, to debug any potential issues, and just in general have a good experience to explore all the DECO features. So I'm going to show you a short demo, a contrived demo about how you can use the playground to use the Discord API to prove that a user is part of a Discord guild. So if somebody can help me to switch on the video, please. Cool, thanks a lot. So we'll start off by just creating a new configuration. I'll just call it SmartCon. And the thing with DECO, the first thing that you do is just you add API endpoints to call. So let's add a guilds API call. We're going to fetch the user, the current user's guilds, the guilds that he's registered in or she's registered in. And this is an authenticated endpoint, so we need to add an authorization token. And notice that I'm adding it in the secret values section, which means that this value is not visible by the verifier. It stays within the TLS encrypted session. You can also see that DECO helps you see the results, so you can tune your request to make sure that it works. And now let's add a predicate. We want to make sure that the user is logged in this dummy guild that I just created before the demo. So first of all, we need to mark all the guild names as being private. I'm using JamesPath here to do that, a JamesPath query language. You can test the path to see that it works. I'm selecting includes any of as the predicate, and I'm saying that the guilds that the user is logged into has to contain, the set of that has to contain the word dummy. So by default, all the response data in DECO is private to the verifier. But that actually, in our experiments, turned out that that actually makes the attestation protocol quite slow. So what you can do to tweak this, you can specify the parts of the response that are public. And I just showed you a way to use JamesPath to select a subset of the response that is public. And you can also add predicates in that. Not all predicates have to be computed in zero knowledge with complete privacy. You can do that on top of public data as well. So in here, I'm just checking that the user is not the owner of the first guild. Again, a contrived example, but something to give you an intuition about what can be done with the playground and with DECO. There are a bunch of other features, like testing that this JamesPath query actually works. You can add any sort of extra data to the attestation that is signed by the verifier. And this is useful particularly when you're integrating DECO into your project. You want to add things like your own user IDs or any other metadata that's maybe consumable on chain. Your contract needs it. You can see the entire configuration, and then obviously you can run the configuration and see the result. And what I'm showing here is just a raw result that is retrieved by the prover, but also the attestation itself, that large hexadecimal encoded structure contains the result from the key binding, the result from the application of the predicate and the response of the predicate. And also there's a signature and a public key that you can use to check on chain. So you've just seen me using the playground to configure a predicate to check that the user is part of a specific guild of interest. But apart from the playground, we've been working on other improvements that I won't have time to go into details, like you've seen the Ethereum optimized attestations. We've introduced support for ARM processors. But I want to draw attention to we've been hard at work kind of documenting the things that we're doing in DECO, and in particular, there's a series of blog posts authored by my colleague Siam, in which we go into details over how we ensure context integrity. In other words, DECO being such a low-level and flexible tool, we have to make sure that provers can't cheat. So if you're interested in how that's done, please have a look at this blog post. And finally, you have seen me demoing and kind of talking about how we've been hard at work improving the usability of DECO in the last year. We've opened it up to a small number of people, mainly academic partners and industry friends. But now it's time to open it up. And so if you're interested, please use this link to sign up to give it a try. And with that, I want to thank everyone for listening to me. I appreciate it. Thank you.